Quick poll, who here is using Kubernetes today? With machine learning? With big data? With sort of-ish? Okay. That's probably not a bad thing. And yeah, I have my own opinions. I've been using Kubernetes with machine learning since 2016. And if I could get back all the time that I spent trying to debug the NVIDIA Docker and all the 10 layers of Kubernetes cruft, yeah, I would love to have repositioned that back into some more data science-y type tasks. But today, so I broadened the talk a little bit to include SageMaker and then EC2, also the Elastic MapReduce. So I've got Ray running on like all of these platforms. Oh yeah, and my name is Chris Fregly, co-author of a book we released. Me and my co-author released this last year. Still very relevant, even though things in this space have change or like tend to change pretty quickly. The book, we wrote it to be pretty sort of long lasting, shelf life. But yeah, we also cover Hugging Face. So who here uses Hugging Face for any tasks? Okay. And then my old coworker is actually doing a talk right now. He left my team and then went to Hugging Face. So yeah, he's speaking right now. So yeah, maybe check it out some other time on the recordings. Principal Solution Architect, I've been with AWS for about 3 years now. Went to the dark side. I always had startups and fun things and, decided once the gray started to set in, decided just to, chill out, get a paycheck, lose some weight, eat right, go to the gym. So that's what AWS has afforded me. All the code here can be found on that GitHub repo. I think they're going to post the slides and everything. I just uploaded them recently, right before this talk. There's also lots of recordings on YouTube. And also there's the book. I've already given out 4 copies. I do have 1 copy that's acting as my stand here that I'll hand out to whoever the first person is to come up here, I guess, after the talk. But and then I shipped them out here from the US, so they're actually signed with me and my co-author, which is kind of fun. All right, so what is Ray? Who here is using Ray currently? All right, so you'll have a lot of questions. Yeah, you guys will have a lot of questions, probably. So Ray is another, I call it yet another like Berkeley, product or like project. So Ray comes out of the next generation lab from Berkeley where Spark came out of. And it's actually backed by a company who the founder came from Databricks. He's the professor, we call him the professor, kind of casually in the Bay Area because he, gets these graduate students up to a certain level and then ships them off. And he's built like 3 companies now in the same formula. So that company is called AnyScale. I'll show some snippets of AnyScale here in a bit, but this is mostly about the open source project. To give you context, Ray hit the 2.0 release just a few weeks ago. Always nice to kind of know which version that you're dealing with. So quite a lot changed. I think the 1.13 was the last version that was on 1x. 2x has this what's called AIR, which is the AI runtime, and that's really what we'll be covering today, and some of the newer features there. So what is Ray? I would say so Ray is sort of this layer that you write to, and you can plug in PyTorch, you can plug in Hugging Face, you can plug in TensorFlow. It's really all about the sort of interactive machine learning story. And this is something that the Spark folks did really well, Databricks did really well, the folks out there, where they made Spark usable. They made Spark so that you could spin up clusters and then tear them down. And so that's exactly what these AnyScale folks are doing with Ray. So Ray also has, yes, I'll talk about the like top features here, but really this frictionless transition from your laptop to a cluster is super, super powerful. And it's kind of the same way where you can, run a Spark job locally on your laptop, and then you can then point to a Databricks cluster or a remote Spark cluster. And then, now one thing that's interesting about Ray is they actually learned quite a bit from their Spark days. And so the professor has these, grad students who are all now, full-time employees of any scale. Like you can see little bits of where Spark was kind of shitty, and they've made it like quite a lot better now in Ray. And so I'll talk about some of those areas here. But the ability to really do this sort of, from your notebook to the cluster with your TensorFlow, with your PyTorch, is very powerful. Ray also supports, of course, XGBoost. Actually, Ray supports Spark, too. It's not the best combination, because Ray is C native with very, very strong Python bindings. Yeah, I would call it Python native, but it's really C native. But as far as, like all of us are concerned, we'll be writing Python code and not necessarily writing the C code. But there's no JVM involved, so this project doesn't have all that legacy that Spark had with like Hadoop and all the Hadoop libraries and the like HDFS connectors. Ray is also very cloud native too, so it has like highly optimized ways to pull data from S3, from Google Cloud Storage, from the Azure Data Lake Storage, all that. Ray also gives you the ability to sort of have Conda as a service. So I could create a Conda environment, name it, and then I could just reuse that, like across all my different teams, and handles all of the environment management. And so this was an area that Spark was not really good at, that Ray does quite a lot better. At the end of the day, it just makes your like machine learning code much easier to scale. You could take scikit-learn actually. So some of you might be familiar with like Dask, and Dask is okay and has its kind of quirks and whatnot. There's a company behind Dask. I actually forget what they're called now, but and so the ability to take basically any Python code and then make it distributed, right? All right, this is a standard slide here that you really can't have a Ray talk without this slide, but sort of shows like the entire ecosystem. The very, very first use cases for Ray came about maybe 5 years ago in that same Berkeley lab where they were doing a lot of reinforcement learning. Very, very niche kind of space, kind of fun, right? You could balance polls and do all kinds of stuff, but not particularly useful to the everyday practitioner of like data and machine learning. So, and then Tune came out. So this is a way to do hyperparameter tuning. Of course, you can't have any machine learning library without hyperparameter tuning support. I'll talk about that here in a bit. Ray Serve. And so I want to draw a parallel to Spark, where when Spark came out, Spark had machine learning, Spark had graph. Spark, of course, had data frames, well, had RDDs, and then changed into data frames. Spark never really had a good kind of workflow. I remember, yes, I used to work at Databricks, and our answer to workflow was just build a Databricks notebook and have if statements in there, and that was your pipeline. And so, Ray learned from this and has actually built in native workflow. These things compete with like Airflow and, compete with like some of the other sort of like workflow engines, pipeline engines, but it's nice to see that things are actually native. Yes, I'll give one super interesting, at the Ray Summit about 2 or 3 weeks ago in San Francisco, I think VP of like AI for Uber was on stage, and they were begging the AnyScale folks, the Ray community, to build Ray SQL. yes, if you notice, Ray SQL is not on here. There is no such thing as Ray SQL. Ray right now is really, really focused on just getting data into these machine learning like algorithms and to saturate GPUs, to saturate CPUs. As some of you might know, we're typically not compute bound, right, with our jobs. Like we have super fast GPUs, yeah, the NVIDIA folks. We've got like custom hardware coming out of Amazon, of course. It should be coming out pretty soon. Can't say when, but it should be next week sometime, probably. Something called Trainium that was announced last year that they're finally able to now get the hardware and you know, catch up with the demand. And so with these fast accelerators, the bottleneck is getting the data into those accelerators, right? And to do the shuffling and, you know, with like distributed training, you have to be very careful how you shuffle, right? And you want each GPU to shuffle and, you know, a lot of different techniques there. And so that's really where Ray's sort of bread and butter is right now, yeah, as we like might say. So it's an area that has typically been sort of under like engineered throughout the years. You know, TensorFlow has like TensorFlow Dataset APIs. PyTorch has distributed data parallel, DDP, but they're all just a little bit shy of being able to saturate all of these accelerators. And so seems like a pretty narrow space. In fact, I didn't quite understand what this Ray project was doing or how that company, Anyscale, was able to get most recently a $100 million Series C funding, you know, just on this sort of, right, like super narrow use case where they're trying to saturate GPUs. But the savings, right, that you're paying for these GPUs, but you're typically only just getting 30% utilization, you know, 25%. And so just this week, I actually was able to saturate, I had 8 GPUs. I was able to saturate all 8 of them for 4 hours, 100%. Yes, I've never seen this before in my life until this week. I was working with the Ray folks over at like Anyscale to try to optimize things on AWS. And it was one flag that was basically like the turbo flag. And once I figured out that flag, yes, everything got a lot better. So I kind of went a little deeper here on this slide, but we'll get to more here. This is sort of the larger ecosystem. There's integration with something called MLflow. Does anyone here use MLflow? Same group of people, yeah. For the experiment tracking. So this is useful when either you're doing like hyperparameter tuning where you're running different variations of your model and then trying to like compare the results. There's integration with weights and biases, which is similar to MLflow, but more of a commercial product. And of course, there's light GBM support, there's XGBoost, Hugging Face is the little, you know, smile emoji there, the waving emoji. And of course, Ray works with all of the major cloud providers and Kubernetes. That's the little blue, you know, nautical symbol in the bottom right there. So we'll talk a little bit about that. Okay, just kind of a quick little slide here. Think of it as you can go from your laptop to the cluster with one line change. So instead of pointing to your local host, you point to the remote cluster. And yes, I really like this image here. You see, you know, same amount of time, I think it was, what, 4 minutes in? On the left, you know, we made it to about 2% on the laptop that has 8 cores or 16 cores. When you change that single line of code to now point to a cluster, that same exact code gets submitted to that cluster. That cluster has 72 CPUs, has a whole ton of RAM, and the same amount of time, we're almost done. We're at 95, 96%. With just one small change to your code. This is the high-level sort of cluster architecture here. If you're familiar with Kubernetes, you probably know something called a kubelet. Kubelet sits on each physical node and handles some of the communication and the scheduling. Ray is very similar. Ray has something called this global control store, right? And this is sort of, so this is the ability to point to memory on like different machines, move that data over if you need to, or just keep the data there and then process in parallel. And so on the right here shows we've got a single, and so Ray is very similar to Spark in that there's a single leader node, which they're making high availability, so there'll be multiple, and then n number of these Ray workers. Okay. There's also debugging tools I'll show here in a bit, profiling tools. All of these things have been built in, and me coming from Databricks and knowing how difficult it was to debug these distributed, Spark jobs, they've actually built in this sort of distributed debugging capabilities right into Ray Native. It's got a nice UI too, which Spark always had kind of a janky UI. So they put a lot of work into there. Also, Ray can support these heterogeneous clusters. So I can have CPUs, I can mix GPUs. Here I have my head node is a fairly large RAM heavy, right, like memory heavy R5DN4XL for the instance type. And then I have my workers, which are then GPUs, right, like pretty big GPU, 48XL. So that's really nice to have the heterogeneous. Okay, if you kind of poke around the docs a little bit, you'll get to see some of the AWS specific things. We have CloudWatch integration, which is how we log all of these nodes that are participating in the cluster. We've got the EFS, which is basically NFS, yes, in the cloud, and really, really simple scripts. So bottom left there, those create scripts, Ray up, Ray down, pretty familiar if you've used things like Terraform and, Ray up, Ray down. Also, there's docs here for like AWS, Azure, and like whatever that other. I have 10 minutes left. Holy shit. Okay, here's Ray up cluster. Let me get to this. Ray cluster dump. So Ray cluster dump is really nice. It'll tell you what's going on with this cluster. We'll actually pull down all the libraries. It'll tar everything up. Super cool. Has this pip packages here, so you could see which pip packages were installed at the time of this cluster. There's also auto scaling that's built in here too. So you would say min 5, maximum 10. You can give it a auto scaling speed. Quick view of the dashboard, so you see all the nodes that are participating, see how much memory. If you are going to start doing Ray, give your nodes a lot of disk. Ray uses disk, it uses memory, but it's constantly spilling to disk for things. Not a very strong suit of Ray right now. If you do run out of disk, it craps out and you don't really know why. So quick tip on that. A little bit more about the sort of local development. So let's see. Here's how you would start your session with Ray. So you do Ray init. And you could tell it, per worker for this particular trainer. So this is a PyTorch training job, for example. And you would say per worker, I want to pull in 4 CPUs and in this case, 0 GPUs. You can also, so that was the interactive part here. So I can create the session and then I can interactively run my commands on the Ray cluster. I can also submit jobs here, okay? You can provide conda-YAMLs, you can provide, pip installs. You can even run, little initialization scripts also when you're starting up these jobs. So all of these things, again, were sore points within Spark that are now much, much better. This is that Conda as a service that I was talking about, where you can sort of tell the cluster here's a named runtime environment, and here's all the characteristics. Use that and just pass the name in. Ray debugging, this is distributed debugging. I can actually set breakpoints in a distributed manner. You don't do this a whole lot, not unless you're really building some of these libraries, but it's kind of fun to know that you could do that. So here's the AI runtime environment, or Ray Air is what it's called. This is really the next generation of training and tuning. Also includes data sets, the serving, of course, reinforcement learning. Some quick sample code here, standard scalar. Ray data, ray train, ray tune, ray serve. You could checkpoint to S3. So when you're doing distributed training, you want to, train, and then checkpoint, maybe every, couple iterations, epochs, whatever. Now here's the key. Ray Dataset is not yet a replacement for Spark. And so back to that like Uber person that was on stage, she was asking Anyscale, look, we're using Ray for all of our AI, but we still have to use Spark to do our, like heavy transformations and joins and things. And so right now, Ray Dataset actually has blazing performance. This is something that, like the Amazon.com folks, I work for the AWS, but the Amazon.com folks locked into Ray about a year ago, and parts of that business are actually replacing Spark with Ray. I mean, it's blazing performance for certain workloads. So not joins, but if you're doing transformations, if you're and so here's some performance characteristics. Just reading in small data set here, and then grouping by sentiment. This is like positive, neutral, negative sentiment. This took 7 seconds on, this is a fairly big data set here. That same exact thing. Oh, and there's this project called Modin too that I do want to highlight. This is Pandas on Ray. Now they also support Pandas on Dask, but today is not a Dask talk. But this is a way, it's a drop-in replacement for Pandas, and now you can scale Pandas out to a cluster. So this is a super interesting project. And that took about 7 seconds. I do want to compare this with Spark on Ray, which had to start up a JVM, and this is awful, and yeah, I wouldn't recommend this. It's not that the Ray DP project necessarily, which is actually not part of the core Ray project, but it is someone else maintaining it. It's the ability to do your current Spark jobs on Ray. But that took about 18 seconds for the same exact job. Okay, Ray Tune, a lot of folks ask, what are the hyperparameter tuning like algorithms? So they do have hyperband in here, Bayesian, hyperopt, all the normal citizens here. Okay, and then like I said, so Ray started off with this reinforcement learning situation, and they were really trying to see how far they can go with that. To me, this felt like the initial Tesla Roadster that like appealed to me and maybe a handful of people here. But there's a whole lot of people that want to know more about the AI runtime, about the dataset APIs, the serving APIs, the ability to serve. So boring, but this really is going to be the next generation. And I didn't put it on here, but seeing Ray SQL show up here at some point, I would estimate maybe not next year, but possibly the year after. There's this sort of gentle person's agreement between Databricks and like Anyscale. This is totally my opinion, where they don't want to tread on each other's. It's the same investors, it's the same CEO. That left Databricks, became CEO of Anyscale. And so when you hear talks by the Anyscale folks, they always kind of dance around that they're not that don't use us for Spark workloads, and that's not where we're going. But I think we all know at some point that they do have to appeal to the masses. And quite honestly, Ray SQL has to be there at some point. Ray Serve. The key takeaway here is that with Ray Serve, you can build ensembles, and you can build DAGs, and you can join the the predictions from two different models. And I actually have a screenshot here. So I have two different BERT models. I'm making two different predictions. There's a review coming in from a customer. We're trying to figure out, is it negative sentiment, is it positive? And I can actually average those two. Maybe one model said it is positive, one model said it was negative, so we'll label it neutral. But you can build these complex DAGs. And yeah, we're in London, so I'm sure some of you know about a company called Selden, yes, I've been to their office. Yeah, great folks. Selden's kind of claim to fame is that they can do these sort of complex DAGs. And so, keep an eye on RayServe because they're definitely thinking about this. Yeah, just some of the low-level details about how to actually set these up. RayServe actually submits this long-running job into the Ray cluster. And so RayServe can actually acquire GPUs and serve using GPUs. So here's an example. RayServe is great, got a 1. Serving frameworks without DAG support are not great, it's -1. Okay, Ray workflows. If you're familiar with Oprah, yeah, right, like you get a workflow, you get a workflow. Yeah, everybody gets a workflow. So of course, Ray has workflow support here. Here's how you would set up the different steps. Yeah, honestly, RayServe still needs to be engineered and made, a bit more full-featured. Ray Workflows is in the same boat. It's still early days. I wouldn't bet the, house on Ray Workflows right now, but pretty cool stuff. There is an MLflow callback while you're training. It'll write to the MLflow. This is a pretty cool project called KubeRay, and there's a really good blog post out here by the Shopify, not Spotify, Shopify. I always type Spotify and I can never find it. KubeRay is actually being supported by the AnyScale folks also. It's a separate project, but this really gets you, the ability to run Ray clusters on your Kubernetes. Okay. And we've also created, yes, we have something called EKS, which is the Elastic Kubernetes Service. There's this whole set of blueprints that we just added one for specifically for the Ray Summit for Ray. And this is all Terraform based. It'll actually spin up a Kubernetes cluster, installs KubeRay, and then you could start training models on your Kube cluster. I don't have time for the demos here, but all the demos are in, really this link here. Got the AWS samples for Ray. And thank you very much.